Welcome. This video is on the C++ rule of three. This is a rule of C++ programming that deals with a particular kind of subtle bug that can happen when you are dealing with dynamic memory or other resources. It's a little bit tricky, but it's something that needs to be said in order to manage memory properly. So remember the RAII discipline, its resource allocation is initialization. The basic idea is that the constructor is solely responsible for new. So our memory allocation should happen in constructors of classes, and the destructor of a class is solely responsible for delete. So all of the memory freeing should happen in the destructors of classes. And if we follow that in a disciplined way, then we can make sure we don't have memory leaks, because every time an object is created, the constructor gets called, and every time an object is destroyed, the destructor gets called automatically without fail. And so we won't ever have memory leaks if we follow this principle. The rule of three is a rule that's kind of implied by that. And that rule says that if a class defines any of these three special functions, it has to define all of them. The three special functions are the destructor, responsible for freeing resources owned by the object, the copy constructor, which is a constructor that copies from one object to another, and the copy assignment operator, which is overloading the equal sign operator that copies from one object into another. So the rule of three says if you write a class and you define any of these three functions, you have to define all three. It's kind of an all or nothing. I'm not allowed to only write my own destructor but not write the other two. I have the option of defining none of those. I can write code for none of those three and I'm good, or I can write code for all of the three, but you can't pick and choose. Let's see why this is. This seems kind of arbitrary. There's a specific reason. There's a bug that can happen when you initialize some but not all of those three functions. Those are the member functions that deal with initializing an object and freeing its memory. So by the RAII principle, those are obligated to handle new and delete. New and delete needs to be handled perfectly in those three functions: the destructor, the copy constructor, and the copy assignment operator. So the destructor is called to destroy an object, and it's responsible for deleting data members that need to be deleted. The copy constructor is called to make a copy of an object, and it needs to actually make a copy, and the copy assignment operator also needs to properly make a copy using the equal operator. Let's look at a concrete example to kind of illustrate what's going on. I'm going to invent a class called maybeInt, and what a maybeInt is it might hold an integer that's stored in dynamic memory allocated with new, or a maybeInt might hold nothing at all. So that's why it's called maybeInt. It might be an int, it might be nothing. This is just an example to illustrate the rule of three. It's not the most useful thing. We're just trying to have an example to make this concrete. I'm kind of bending the single responsibility principle here. The single responsibility principle says that when you're designing classes, it's best to have a class be responsible for just one thing. So the concept of maybe having something or maybe not, that's one concept, and then the int is another concept. It would really be better to have one class for things that may or may not exist, and then use an int for that. And there's something built into the standard library called stdOptional, and that's a class that could hold something or could not hold anything. And if I was writing code where I needed to maybe hold an int, I would do an optional int. That would probably be a better coding practice. But anyway, let's look at our example. So this code has a bug in it. Keep that in mind. This is not good code. We're illustrating the problem when you break the rule of three. Here's my class maybeInt. I've got a constructor, and the data member here is an int star value. So that's a pointer to a int. And my idea is that that pointer could be null when maybeInt holds nothing. And if maybeInt is holding an int, then value is a non-null pointer. So the default constructor initializes the pointer to null. That means we're not holding an int right now. There's another constructor that takes an int value where we do hold that value. And so I initialize value underscore with a new int. So I'm allocating a new int dynamically, and it holds the given value. And then the destructor has this logic that says, value might be a null pointer at this moment. It might be non-null. So if value is non-null, then value is a valid pointer that needs to be freed. We delete value. This looks pretty innocuous. At first glance, this looks okay. You might not see a problem with it, but it's breaking the rule of three, and it's possible to use this class in a way that creates a memory leak. Here's how I could use it on the right. So I've got my int main, and I create a maybe int a that's holding a 7, a maybe int b that's holding a copy of a, so b should hold another 7, and a maybe int c which is holding nothing, and then I'm saying c is a copy of a, so c should now hold a 7. This can have a memory leak. Let's see how this works. So this first line of code here says a value is now pointing at an int 7. Okay, so far so good. The second line of code says create B with a copy of A. Now, my code did not define its own version of the copy constructor. So the default copy instructor makes a copy of every data member. So what that means is that B gets its value to be a copy of A's value. So now B's value is pointing at the same object, the same int object. And this is where the problem comes in. Later, when the destructor tries to free this, we'll have a dangling pointer problem. So at this moment, after the second line of code is executed, A's value pointer and B's value pointer are both pointing at the same int object. C uses the default constructor to point to null pointer. So right now on the third line of code, C value is null. And then C equals A. This is going to create this, make this problem get worse. C's value moves to point to the same object as 7. We haven't crashed or anything yet. That's going to happen next. When the objects go out of scope, the destructor for A gets called, and then the destructor for B gets called, and then the destructor for C gets called. Let's look at what that code does. It says, if my pointer is not null, delete the object. Okay, so when we get to the close curly brace of main, here's a sketch of what's going on. A, B, and C all have value pointing at the same int object. A's constructor goes first. It deletes 7, so I'm going to draw this as now an invalid location. That means the B value and C value pointers are invalid at this moment. We're still okay, but the crash comes in when B's constructor gets called, and B's constructor will try to delete this memory location. B is still pointing at a non-null value, and so the code tries to delete this invalid pointer, but this memory location was already deleted once, and you're not allowed to delete the same memory location twice. So we'll get a crash at that moment when B's destructor runs, and it's pretty kind of subtle. Like, why is that happening? You know, it looks innocuous. Well, it's a double delete, and that's a crash. So here's what we have to do to fix this. The rule of three needs to be invoked. I broke the rule of three in this code because I defined my own destructor and I did not define my own other two functions. I didn't define my own copy constructor or copy assignment operator. So I need to go back and write all three of them. Okay, so yeah, so all three initialization functions have to do a new, the copy constructor needs to do a new, and the copy assignment operator needs to do a new. So here's a modified version of this code that has that bug fixed. Most of it's the same. I've highlighted in yellow some new functions that need to be written. Everything else is the same. So the default constructor is the same. This constructor that takes an int value is the same. Here is the copy constructor. So see, it takes a const maybe int reference called other. We're going to copy out of other into this maybe int. And so what I need to do here is have this maybe int allocate its own int with new. And I've got this if statement. If the other one is null, I'm going to ignore it and set my value to null. But if the other value is not null, then I'm going to make a new int, allocate my own private int that's separate from the int object that the other one owns. And then it's going to be initialized with the other's value. The destructor does the same thing as before, and then the copy assignment operator is here. Here I'm overloading the equal operator. This is the copy assignment operator that gets invoked when you do an assignment like C equals A here. And it's actually a copy paste of the copy constructor code. So it says if the thing I'm copying from is empty null, just set my pointer to null. And before we do that, check if we need to free it. If we currently have a pointer, we free that first. And then the same logic. So now if we were to run this, we don't get a crash. It works fine. Let's see how that works. So Now I've got my fixed maybe int. So first line of code, we do a of 7, so that would be calling this constructor here, and a's value points at a new 7. Next, we do b's constructor, and then this is the key difference between our fixed version and the original version. This is doing the copy constructor, so this is my yellow code on the left here. This code executes, and we're allocating a new int object that's distinct from the a's int object. So now we've got two separate int objects. They're not pointing at the same object and interfering with each other like this. The same thing happens when I do c equals a. Before we had a problem where a, b, and c were all pointing to the same object, but now my overloaded copy assignment operator gets run, and that sets all three of them pointing at separate ints that all happen to store the value 7. So now when the destructors happen, we're all good. A's destructor frees that int, and that has no bearing on b's value or c's value. Those can just get freed one at a time, and they don't disturb each other. So we're all good. That bug has been solved. That's the C++ rule of 3.